The following is Spring 2011 Math 115 Test 3, number 16 and 17. Number 16, we need to simplify this rational expression with negative exponents. You are aware that we need to be more careful when we have negative exponent. Let's see the first with the coefficients. You have positive divided by negative, we know that will be negative. Okay, and then both of them seems to be a multiple of 4 and also multiple of 3. Let's divide by 4 first. If I divide by 4 on the top, I get 12. Divide by 4 at the bottom, I get 21. Now I will reduce this further in the next step. Then I will look at the x term. I have x to the negative 4 on the top. I will bring it down to make it positive exponent. And for the x to the negative 8, I will bring it up to make it positive exponent. For the y, on the top I have y to the negative 6. I will bring it down. Becomes y to the 6 at the bottom. At the bottom here, I have y to the power of invisible positive 1. Because it's positive, I will keep it there. Okay. For the z, I have c cubed on the top. That's positive. I will keep it there. And c to the negative 3 at the bottom, I will bring it up to make it positive. Now, what I will do next to go further into my simplification, okay, 12 and 21, both of them multiple of 3. So if I divide by the top by 3, I get 4, I'm sorry. And if I divide the bottom by 3, I get 7. Now, x to the 8 over x to the 4, you can cancel x to the 4th and you have x to the 4th left on the top. Not x squared. You are not dividing 8 over 4. No. What you are doing is 8 minus 4. You see? Okay? And then, as for the y, I will have y to the 7th, right? Y to the 6th times y to the invisible 1, that's y to the 7th. And c cubed times c cubed is c to the 6th. That's for number 16. Number 17, I am multiplying these two parts here, and because we have a lot of negative exponent, we need to be a bit careful. Now for this number 17, I will do it two different ways. The first one, the one I prefer you to do, because even though it's slower, it is more careful. Now it is by doing the following. Whenever I see negative exponent inside, I'll make it into a positive exponent by either bring it down or bring it up. Like negative 2 has positive exponent. X to the negative 3, I bring it down, becomes x cubed. Y to the negative 2, I bring it down, becomes y squared to the power of negative 4 here. Okay, and then for the second factor, negative 3 positive exponent, right? X to the negative 4th, I bring it down, becomes x to the 4th. Y squared is positive exponent, I keep it up there to the power of negative 3. Okay, so you see that so far I'm dealing with the things, the expression inside the grouping symbol only. Now what I will do next, I will make this exponent here, the exponent negative 4 and exponent negative 3 becomes a positive exponent. Now how to do that? Now remember that negative exponent means reciprocal. Okay, so for me to make it positive 4, exponent positive 4 here, what I will do the reciprocal inside the parentheses. So it will be x cubed y squared over negative 2 to the power of 4 times x to the 4th over negative 3y squared to the power of 3. Okay, now notice that we don't have negative exponents anymore. Anyway, we have negative coefficients, but negative factor, but that's not negative exponent. Now what I will do next then is to distribute the exponent to each one of the factor. Okay, x cubed to the 4th, that's x to the 12th. Y squared to the 4th is y to the 8th. Negative to the 4th is positive. 2 to the 4th is 16 times x to the 4th cube is x to the 12th. Negative to the power of 3 is negative. 3 to the power of 3 is 27. Basically, negative 3 cube is negative 27. And then y squared cube is y to the 6th. Okay, now from here then, I deal with the x, I deal with the y's. The x, 12 times x to the 12th, that's x to the 24. Okay, now y to the 8th and y to the 6th, they are on numerator and denominator, so I can do cross cancelling. I have y squared here, and this becomes 1. Okay, because y to the 6th cancelled from both of them. Okay, so I have y to the square here on the top, right? Now the next thing I will do is to multiply 16 by negative 27. We know that will be negative. Now 16 times 27, let me write it down here. No, I don't memorize 16 times 27. Okay, so don't feel bad if you don't. Okay, nobody memorized multiplication by 16 nor by 27, but it implies you have to write it down. Okay, 12, 1, that's 3 here. Okay, and then I add, this will be negative 432. Okay, now that's one way. Another way to do this number 17 here, let me write down the question. Now the following way is a bit risky. Only do this if you consider yourself someone careful enough to handle sophisticated math. Now what I will do right away is I deal with negative exponent directly. Now it is by distributing the negative exponent to each term, each factor there. Negative 2 to the power of negative 4, right? And then x to the negative 3 times x to the negative 3 to the power of negative 4 is x to the 12. This will be y to the 8th times negative 3 to the power of negative 3. Let me write it down this way. Okay, I do not want to compute right away because of the negative exponent. And then x to the negative 4 to the power of negative 3 is x to the 12, and this is y to the negative 6. Okay, now as for the number, this is 1 over negative 2 to the 4th. Later on you will see this will be 1 over negative 3 to the 3rd. Now for the x, this is x to the 12th. Let me copy that down for now. Now notice that we are multiplying, right? We are not adding, we are not subtracting, so we don't need them to be like terms to multiply. Now if you compute this, is 1 over 16. Okay, and later on this will be 1 over negative 27. Eventually later on you will see this is negative 1 over 432. That's the number we get down there earlier. Okay, now and then I will multiply x to the 12 by x to the 12. That will give me x to the 24. And as for the y, it will be y squared, right? Y to the 8 times y to the negative 6 is y squared. Now then, to write this in a more a form that we like, this is what we get. Notice that this is the same answer we have there, right? Okay, this is for Spring 2011 Math 115 Test 3, number 16 and number 17.